Have you ever wondered what makes you, you? What is it that defines our very existence, our thoughts, our actions, and even our emotions? Or what makes a rock a rock? What gives it its solidity, its texture, its very essence? It all comes down to something incredibly small, the atom. These tiny building blocks are the foundation of everything we see and touch, and at the very heart of every atom lies the nucleus. This core is the powerhouse, the command center of the atom. This minuscule, dense center of the atom is like a bustling city, home to particles called protons and neutrons. These particles interact in complex ways, much like the citizens of a city. It's the nucleus that determines what an element is, how it behaves, and ultimately, how our universe takes shape. The interactions within the nucleus dictate the properties of matter, influencing everything from the air we breathe to the stars in the sky. But our understanding of this tiny universe wasn't always clear. For centuries, the inner workings of the atom remained a mystery, shrouded in the unknown. It took the ingenuity and perseverance of many scientists to unravel its secrets. Through countless experiments, trials, and errors, they slowly pieced together the puzzle of atomic structure. Let's take a captivating journey back in time to explore how the nucleus was discovered and why it matters. From the early theories of ancient philosophers to the groundbreaking experiments of modern physicists, the story of the nucleus is a testament to human curiosity and the relentless pursuit of knowledge. Our story begins in the late 19th century, a time of great scientific curiosity and discovery. Among the many brilliant minds of this era was a physicist named J.J. Thompson, whose work would forever change our understanding of the atomic world. Thompson was particularly fascinated by mysterious rays that could travel through a vacuum tube, a device that had intrigued scientists for years. Through meticulous experimentation, he conducted a series of tests and made a groundbreaking discovery. These rays were not just light or energy, but streams of tiny, negatively charged particles. He initially called them corpuscles, but today we recognize them as electrons, fundamental components of the atom. This discovery marked a pivotal moment in the field of atomic theory, challenging the long-held belief that atoms were indivisible. For centuries, scientists had thought of atoms as the smallest units of matter, indivisible and solid. Thomson's work provided the first evidence that atoms were composed of even smaller particles. These subatomic particles, the electrons, revealed a more complex structure within the atom, suggesting that there was much more to discover. However, this discovery also raised new questions. If atoms contain negatively charged electrons, what prevented these charges from repelling each other and causing the atom to fly apart? There had to be some form of positive charge within the atom to balance out the negative charge of the electrons. This realization sparked a new wave of scientific inquiry as researchers began the search for these positive charges, leading to further discoveries about the atomic nucleus and the true nature of atomic structure. Enter Ernest Rutherford, a physicist who was a student of Thomson's. Rutherford devised an ingenious experiment to probe the structure of the atom. He fired a beam of positively charged particles, called alpha particles, at a thin sheet of gold foil. He expected most of the particles to pass straight through, with maybe a slight deflection. What he observed instead shocked the scientific world. While most particles passed through, some were deflected at sharp angles. A few even bounced straight back. This was astonishing, like firing a cannonball at tissue paper and having it bounce back. Rutherford concluded that the atom must have a tiny, dense and positively charged center, the nucleus. Section 4. The elusive neutron completing the atomic puzzle. Rutherford's discovery of the nucleus was revolutionary, but the story wasn't over. Scientists knew that the nucleus contained protons, the positively charged particles. However, the mass of the nucleus suggested there was something else in there, something neutral. In 1932, physicist James Chadwick finally found the missing piece of the puzzle, the neutron. Chadwick discovered this elusive particle through a series of experiments that involved bombarding beryllium with alpha particles. Neutrons, as their name suggests, carry no charge. They reside in the nucleus alongside protons, contributing to the atom's mass, but not its charge. Section 5. The heart of matter. Unveiling the nucleus. With the discovery of the neutron, the basic structure of the atom was complete. This breakthrough was monumental in the field of atomic physics, as it provided the missing piece of the atomic puzzle. We now understood that atoms consist of a nucleus containing protons and neutrons orbited by electrons. This model revolutionized our comprehension of matter and its fundamental components. The nucleus, though tiny, is incredibly dense. It is the core of the atom, holding the key to its properties and behavior. It accounts for nearly all of an atom's mass, even though it occupies a minuscule fraction of its volume. Imagine a football stadium. The vast empty space around the nucleus is where the electrons move. If the stadium represented an atom, the nucleus would be like a marble sitting at the center of the field. This analogy helps us grasp the scale and density of the nucleus. Despite its size, this marble holds almost the entire mass of the stadium. The protons and neutrons within the nucleus are packed tightly together, contributing to its immense density. This incredible density is what makes the nucleus so fascinating and crucial to understanding the universe. The study of the nucleus has led to numerous scientific advancements, from nuclear energy to medical imaging. It continues to be a central focus in the quest to unravel the mysteries of matter and the forces that govern it.